For part B, we are told to estimate the radius of the path followed by the cage's platform. And then we'll need to calculate the acceleration of the platform. As the cage rotates around the fixed pole, this is the radius that we need to estimate. We are also told that the diagram here is drawn to scale. So that tells us, that gives us the idea that we need to use the diagram and make some measurements to estimate the radius. The other hint is that it's only an estimate, it doesn't tell us to calculate. So we can measure the radius from the diagram, and the measurement I got was 3.7 centimeters, and this depends on how big your diagram is actually. So that's not a fixed number, but everything will be scaled up and down accordingly, so the final answer shouldn't matter. And the other measurement we can do from the diagram is the height of the man there. We can measure that, and my measurement was 2.5 centimeters. What we then need to do is estimate the height of the man in real life. So let's say an average person is 1.8 meters. That will tell us the scale of the drawing. So the radius should be in the same proportion to the height of the man in the diagram. And if we use direct proportion there, we should get that the radius is 1.8 times 3.7 divided by 2.5, and that will give 2.7 meters. Then we can look at calculating the acceleration. Centripetal acceleration is given by two expressions. We have got v squared over r, and we also have omega squared r. But in this case, we don't know the velocity, so we don't really want to use that one. We have just calculated the angular velocity omega in the previous part, so we can use omega squared r. And if we say 2.1 squared times 2.7, the acceleration should be 12 meters per second squared.